Hi, sixth grade. Russo here. Today we're going to talk about displacement. Displacement is when something takes the place of something else. Easy example. You are in the lunch line. You're waiting for lunch, and some jerk comes in and pushes you aside and takes your spot in line. They displaced you. They took your place. And if that ever happens, that's not okay. Well, here we have a full container of water and a bowling ball. And this bowling ball is going to be put in the water. Now the water completely fills this container. So when the bowling ball goes in, water is going to spill out because the bowling ball is going to take the place or displace the water. Sorry. This water right here takes up the same amount of space as the bowling ball. So if we were to measure this water, we would find out that the volume of the water would be the volume of the bowling ball. Let's see how we can use that in science. Here we have a graduated cylinder. Now, water is sticky, and because it's sticky, it's going to want to climb the sides of this graduated cylinder. It's going to want to climb the sides of anything, but it's easier to see in a graduated cylinder than a swimming pool. So when you read a graduated cylinder, we're going to read the bottom of this curve. The curve is called the meniscus. And when you read the bottom, that's the most accurate way to measure a graduated cylinder. You're going to see a couple of those in pictures. Okay, here we have some water, and here we have some wood. Well, how much water do we have over here? Well, we have exactly 15 milliliters. I counted. Once we added the wood, the water level went up because the wood displaced some of the water. How much water? Glad you asked. Well, now we have 21 milliliters of water. I know what you're thinking. Aha, there's 21 milliliters of water. That's the volume. You're close. That's the volume of the water plus the wood. But we want to know, what is the volume of just the wood? We started with 15 milliliters. We added this thing, and now we got 21 milliliters. So wood plus 15 milliliters of water get to 21. Let's say something plus 15 equals 21. Oh, well, you could just do 21 minus 15. That would be 6. The wood is 6 milliliters. That's its volume. That's how we can find out the volume of anything if you put it in water. You put it in water, you measure how much the water displaces, and then the difference between the initial amount of water and the final amount of water has to be your object. Let's try it again. Here we have a beaker. And in this beaker we've got, let's see, 10, 20, 30. That looks like, it's about 13 milliliters. Sorry about my handwriting. It's hard to write on a touchpad. And here we have a blue block of something. And we stuck that in our beaker. And the water level went up from here all the way up to here. So the final level of the water would be, let's see, that's 13, maybe like 16.6, that's 20. So that would be 23. Okay. Now, before anybody realizes my mistake, I'm going to use units because you always need to use units when you measure stuff. The final volume is 23 milliliters. That's the water plus the cube. Well, we started out with 13, we added this thing right there, and now we went up to 23. So the cube has to be the difference between 13 and 23. Well, the math on that's pretty easy. 23, take away 13, yeah, that should be 10 milliliters. And let's check. 10 plus 13 equals 23. And yep, that's 23 right there. Okay, I think we've got it. Now, I'm going to let you try this one on your own. But I'll walk you through some of the basics. We have 50 milliliters. We have what I can assume is a block of cheese. And then we have 60 milliliters. The question is, how much cheese do we have? I'll wait. By now, you should have said, oh, let's see, we have something plus 50 gives me 60. What plus 50 would give me? That should be 10 milliliters. If you said 10 milliliters, great. And the faster you thought of it, the more you really got this idea. Now this idea is a very old idea, and it came from a really awesome story. I'm going to give you kind of the basics right now because I think it's a great story, and then we'll talk more about this later. I'm only going to give you half the story though. Here in Sicily, which by the way, randomly is where some of my ancestors came from, we have this guy. His name's King Hero. He's a real king. And he wanted a new crown because he thought he was pretty cool. So he goes to this guy over here, the goldsmith, and says, hey, goldsmith, I need a new crown. And the goldsmith says, hey, no problem, but I don't have any gold. So if you want a gold crown, you're going to need to give me some gold. King Hero's like, that's a great idea. Give you some gold. And a couple of months later, the goldsmith comes back with a beautiful crown. There's just one problem. The crown looked like it was a little bit bigger than the amount of gold that he gave him. And King Hero is no dummy. He knows that sometimes people mix silver, which doesn't cost as much, with the gold, keeps some of the gold, and he takes his payment as being a goldsmith, but he also rips off the king, which, by the way, you don't want to do. It was also very suspect that this guy's name was Tritu. His full name was Tritochetus, so it's a little suspect right there. The problem is, King Hero can't figure out if this is gold plus silver unless he melts down his own crown. Well, he can't do that. He likes the crown. He wants to keep it. So he goes to his buddy Archimedes, and he says, Archimedes, look, I need you to figure out if this is pure gold or this is gold plus silver, but I need you not to destroy the crown. Good luck. So Archimedes thinks about it a lot. And he's really trying to figure out, so how can he figure it out? And he's like, well, I could do it mathematically. But as you know, that crown doesn't have a lot of, right angles, and you can't do a lot of length times width times height on that one. So he needed to find a better way to figure out how much space it took up. Then he could compare the space the crown takes up with the amount of gold that was given to him initially. Well, after a while, Archimedes gets tired and he decides to take a break and take a bath. When he takes a bath, of course, as you can figure out, he takes a full bath. And when he gets in, some water spills out. And he's like, wait a minute, something's going on here. And he's like, aha! He realizes he can measure the amount of water that's spilled out of the bathtub. That's going to be a lot easier to measure than he would be. You couldn't fit him in a graduated cylinder, but you can fit the water in a graduated cylinder. So Archimedes gets so excited that he decides to use this to help the king out. I'll tell you the rest of the story later on. Okay, 6th grade, that is how displacement works. Now, I want you to try it on your own. In your notes, you're going to answer the following 3 questions. But let's review. This is displacement. When an object pushes aside the water level rises, and we can measure that. Here we have 80 milliliters of water plus a sphere. Well, when we add the sphere, we now have 100 milliliters of water. So something plus 80 must equal 100. And whatever that something is happens to be the volume, or amount of space, this sphere takes up. Well, if 8 plus 2 equals 10, then 80 plus 20 must equal 100. Now remember, this volume is not 100. This is the volume of the water plus the sphere. That's an important tip that a lot of people mess up on. So here are 3 questions you're going to try on your own. Here we have a pipe, and we start with, that looks like 19 milliliters of water. You can see the meniscus on both sides there. And then it goes up to, that looks like 29 milliliters of water. You're going to answer that one, and you're going to call your answer for letter A. Over here, we've got 64 milliliters going up to, I'm going to let you sort that one out yourself. But I want to know, what is the volume of the ring in this situation? You may want to freeze this, work it out, write it down, and then hit play again. Okay, we're back. If you're just joining us, we are trying to figure out, for C, the volume of this kryptonite. Now, a little bit of a math trick, don't be fooled. We started out with 50 milliliters, we're all the way up to 60.5 milliliters, so don't mess that one up. Figure out the volume of the kryptonite, not the volume of the water and the kryptonite, just the volume of the kryptonite. Write that down in a margin somewhere. You're going to need that for your notes. That's it. Good luck, and if you have any questions, talk to a few other people before you raise your hand.